Hello, Ms. Treadway here to kick off our Chapter 8 notes. We are starting with Section 8.1. And so the first thing we're going to talk about is a little bit of vocabulary. So you are already familiar with ratios and proportions. You just might not have called them by that name before. So first of all, a ratio is a quotient of two numbers. Now remember, a quotient means to divide. So a fraction is division. So a ratio is really two fractions. A fraction. A proportion is an equation stating that two or more ratios are equal. So a proportion are equivalent fractions. So, for example, A over B is equal to C over D. A over B is a ratio and C over D is a ratio, and the equivalency of the two is the proportion. So if we number our terms, 1, 2, 3, 4, so 1 and 2 are on the same side, 3 and 4 are on the same side. The first and fourth terms are what we call extremes. So A and D would be our extremes. And the second and third terms, B and C, are the means. So that's just some terminology there when it comes to our proportions. And so we have two theorems that are basically stating the same thing one way and then backwards. So in a proportion, the product of the means is equal to the product of the extremes. And we get this by doing what you may have seen in the past as the butterfly method or cross multiplying. If we cross multiply or butterfly our proportion, we get the expression A times D is equal to B times C, or the product, the multiplication of our means, and the multiplication of our extremes. Okay, so we can also write that the other way around. If we're starting with the product of these two, we can write it into the proportion. So one last piece of vocabulary here is going to be the geometric mean. And the geometric mean happens when in a proportion the means are equal. So our means, remember, are 2 and 3. So in this proportion, they are both 4. So it would be said that 4 is the geometric mean between 1 and 16. All right, let's do two quick practice problems. So in this first one, if 3 over x is equal to 7 over 14, we want to solve for x. And so we're going to use that theorem that we talked about at the beginning, which is that we can rewrite the products of the means equal to the products of our extremes, or cross multiplying. So 7x is equivalent to 3 times 14, which is 42. So I can divide by both sides, by 7 on both sides, and I get that x is equal to 6. So that's something you should be pretty familiar with. Now the next one looks a little bit trickier, but it's the same approach. I'm solving for the variable. In this case, it's r. So again, I'm going to cross multiply. So I'm going to have 6 times r minus 10 is equal to r plus 6 times 4. So this looks tricky, but all I'm going to do is distribute on both sides of my equal sign. So I'm going to distribute this 6 to the r and the minus 10, and I'll get 6r minus 60. And on the right side, I'm going to distribute the 4 to the r and to the 6, and I'll get 4r plus 24. And now it's just a simple algebraic equation that I need to solve. So I'm going to get all my variables on one side and all my constants on the other. And I'm going to rewrite this over here just because I'm running out of room. So I'm going to move my 4r over, and I'm going to move my 60 over. And so that gives me 2r is equivalent to 84. So I divide by 2. And the last step is to say that r is equal to 42. And that is it for 8.1. We are going to move on now to 8.2, which talks about similarity. And we're going to first talk about this with triangles. So we have two things that are true in similar polygons. The first is that the ratio of the measures of the corresponding sides are equal. So that means the ratio of each corresponding sides of our polygon, they all have the same ratio. So the quotient of the two numbers is equivalent. They make an equivalent fraction. So that's our first feature. The second one is that our corresponding angles are congruent. And so remember, similar figures are figures that have the same shape but different sizes. So they have to have the same number of sides. So a triangle could not be similar to a quadrilateral, and a quadrilateral could not be similar to a pentagon. They have to have the same number of sides. And there are two ways in which these figures can be similar. They can be a dilation, which means they get bigger. So if you think about if you've ever had your pupils dilated at the eye doctor, you're dilating means you're getting bigger. Or a reduction, reduce, it gets smaller. So dilation is an increase in size and a reduction is a decrease in size. So looking at this first example here, we're told that triangle ABC, this little squiggle, that means similar to. So we're told triangle ABC is similar to triangle DEF. Now, just like when we were talking about congruent triangles, the way in which we name and list the points of our shapes when we're talking about similar figures is very important because it tells us which sides correspond to each other. So triangle ABC being similar to DEF means that A corresponds to D, B corresponds to E, and C corresponds to F. Now I know these numbers are a little small, so I'm going to rewrite them. That's an 8, 12, 10, 6, 5. So let's verify that we have that the ratios of the corresponding sides are all equal. So starting with AB corresponds to side DE because A corresponds to D and B corresponds to E. So the ratio of those two sides would be 8 to 4, which is I can reduce to say 2 over 1. Okay, what about AC and DF? So AC corresponds to DF because A corresponds to D and C corresponds to F. So that ratio would be 10 to 5, which also reduces to 2 to 1. And then lastly, BC corresponds to EF because B corresponds to E and C corresponds to F. So that ratio would be 12 to 6, which also reduces to 2 over 1. So all three sides, corresponding sides, have the same ratio. So that means that they are similar. The other feature would be that the corresponding angles are congruent. So angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. All right, and then one more theorem is that the ratio of the perimeters of similar polygons is equal to the ratio of the corresponding sides. So if I wanted to find the ratio of the perimeter of these two figures, it should be equivalent to the ratio of their corresponding sides. So let's verify that. So the perimeter of triangle ABC would be 8 plus 12 plus 10, which is 30. And the perimeter of triangle DEF is 4 plus 6 plus 5, which is 15. So that ratio would be 30 over 15, which does in fact reduce to 2 over 1. So it's the same ratio as the ratio of the corresponding sides. All right, and we're going to again do a couple quick practice problems and then we will be done with our notes for the day. So in number 1, we're told that triangle JKL is a dilation of triangle MNO. And so dilation means that it's going to get bigger, so that means JKL is larger than MNO with a ratio of 2 to 1 for each pair of corresponding sides. So 2 to 1. The 2 is what we attribute to JKL because it's the larger triangle. And again, I'm going to write these numbers just a little bit bigger because they came out kind of small. So we want to find the length of each side. So first we have to find out which sides correspond to what. So we look at the way that the triangle is named. JKL is similar to MNO. So J corresponds to M, K corresponds to N, and L corresponds to O. So side JK corresponds to MN. So if MN is 5, we find the length of JK by multiplying by 2. So that's going to be 10. Side JL corresponds to MO because J corresponds to M and L corresponds to O. So if that length is 7, I'm going to multiply by 2 to get the length of JL. So that would be 14. Well, and then lastly, side KL, which corresponds to NO, is going to be 18 because I multiply 9 by 2. All right, and then if M is equal to 35 degrees and angle N is equal to 45 degrees, how can I find the measure of angle L? Well, remember that in similar figures, the corresponding angles are congruent. So that means that J corresponds to M, so J is also 35, and angle K corresponds to angle N, so angle K would also be 45 degrees. So I just need to use what I know about the sum of the interior angles, which is 180, so minus 35 minus 45, and that's going to leave me with 100 degrees for angle L. All right, and then one more problem here. We're told that triangle JHK is similar, remember that symbol means similar, to triangle POM. So I'm going to draw these two triangles, and these aren't going to be to scale because I don't know the ratio, but I want to make sure that I draw them as the corresponding parts. So JHK and POM. So H is 90 degrees and J is 40 degrees. M is equal to x plus 5 and O is equal to 1/2 y. So we want to solve for x and for y. So first of all, we know that angle H and angle O are corresponding, and because they're similar triangles, they are congruent. So I can say that 90 is equivalent to 1/2 y. And then I need to multiply by 2 on both sides to get rid of that fraction, and I get that y is equal to 180. Now I need to solve for x, and angle M corresponds to angle K, so they're going to be congruent, but I don't know what K is. But I do know the other two angles, so I can find that K is going to be 50 degrees. So x plus 5 is equal to 50. I subtract 5 on both sides, and I get that x is 45. So there's my x and my y. And that's going to wrap up our notes on 8.1 and 8.2.